Region C. Based on the voltage transfer characteristic curve, the inverter's input voltage is equal to VTH. Therefore, the region in green indicates the NMOS gate source voltage. Based on the KVL analysis at the inverter's input, we know that the gate source voltage of the NMOS plus the gate source voltage of the PMOS will be equal to VDD. Since we know that the gate source voltage of the NMOS is the region highlighted in green, the gate source voltage of the PMOS will be the region highlighted in orange. As we know that the threshold voltage of the PMOS transistor is defined as VDD plus VT not P. Therefore, the threshold voltage of the PMOS transistor will be the region highlighted in brown. By visual inspection, we can see that both the NMOS gate source voltage and the PMOS gate source voltage are equal to half VDD. We can see that both the NMOS gate source voltage and the PMOS gate source voltage are greater than their threshold voltage. Therefore, we can see that both the NMOS transistor and the PMOS transistor are both turned on. Up till now, we only know that both the NMOS transistor and the PMOS transistor are both turned on. To complete the analysis of both the NMOS and the PMOS transistor, we need to determine, are they operating in the linear or in the saturation region? To determine this, we need to know 1. NMOS drain source voltage. 2. PMOS drain source voltage. According to the IV characteristic, the drain source resistance is inversely proportional to gate source voltage. By visual inspection, we can see that both the NMOS gate source voltage and the PMOS gate source voltage are equal to half VDD. Therefore, we can say that the NMOS drain source resistance will be equal to PMOS drain source resistance. We can also see that the NMOS gate source voltage minus its threshold voltage is lesser than half VDD. The PMOS gate source voltage minus its threshold voltage is also lesser than half VDD. With this information, we can conclude that the inverter's output voltage will be equal to half VDD. If the inverter's output voltage is equal to half VDD, the drain source voltage of the NMOS transistor will be equal to half VDD as well. Based on the KVL analysis at the inverter's output, we know that the drain source voltage of the NMOS plus the drain source voltage of the PMOS will be equal to VDD. Since we know that the drain source voltage of the NMOS is equal to half VDD, the drain source voltage of the PMOS will also be equal to half VDD. Therefore, by visual inspection, we can conclude that 1. NMOS is operating in the saturation region. 2. PMOS is operating in the saturation region. In region C of the CMOS inverter, the NMOS transistor is in the saturation region. The PMOS transistor is in the saturation region.